Hi guys, very good evening. Welcome to Gradeup, India's largest live learning platform. Okay, today we are going to have the number representation, the topic under the most 25 important topics for the GATE 2021. So the today's topic is that is a digital logic topic. In the digital logic, a number representation we are going to discuss. Okay, so I hope you will enjoy the session. So before that, please go through this website and you can just subscribe to the channel, YouTube channel. So more than 3,12,000 subscribers are there for the GATE YouTube channel for the Gradeup, right? So without any delay, please go through the channel and you can just subscribe to it, and also you please like the channel. Okay, so now under this 25 most important topics, we are going to have the number representation. So this is a 19th one. Okay, so please actually after the finishing of this topic, if you have any doubts also you can post in the right now live chat, or later on also you can post your doubts in the continuous the chat box. Okay, so that is in the message box, you can do that. Okay, so now before starting of the session, so let me introduce myself. Myself Muralikrishna. I am having 20 years of teaching experience both in the GATE teaching and also I worked in different engineering colleges, and I am topper in one of the NPTEL course in the subject theory of computation, and I stood top in the exam with 96% of marks. And I am also certified as international engineering educator through the ISIP certification program, and also trained more than 50,000 students across the country in different core areas of computer science and engineering. So those are theory of computation, that is a TOC, and then operating systems, that is OS, and computer organization and architecture, COA, and then computer networks, CN, and then DLD, digital logic and design. So these are the subjects where I am familiar with. So this is about my brief profile, and join quickly and you can start the session. So before beginning the session, so there is a small announcement regarding the courses we are offering at Gradeup. Okay, just a moment. So right now for computer science, for GATE computer science, we are offering 3 courses. One is the GATE 2021 and Rank Up GATE 2021, and then Vision 2022. So these are the 3 courses we are offering right now. So this Gradeup course is for the 2021, that is a short term course, and even Rank Up course also same. Okay, but whereas this Vision course is the long term course targeted for 2022 GATE. Okay, so in the Gradeup course these are all majorly for the concept building. So the subject will be taught from the fundamentals, keeping in view of the basics, and you will learn all the basics very clearly. And we are having 300 plus hours of live classes and 3000 plus practice questions, 40 plus mock tests, and also 75 plus chapter wise study notes. And in the Rank Up program, so we are having 300 plus hours of live classes and 3000 plus practice questions, 40 plus mock test, and 75 plus chapter wise study notes. So this Rank Up program is also basically for a score improvement, more emphasis on the problem solving, and it is ideal for the repeaters who wanted to improve their GATE score. Okay, so I hope you have got the idea of the difference between the Gradeup course and Rank Up course. Vision course is a year-long program, so that is 550 plus hours of live classes and 5000 plus practice questions and 100 plus mock tests and 100 plus chapter wise study notes we are offering. So this is how the Vision course is running, and Vision course is basically ideal for second and third year engineering students, because all the core subjects will start from the second year onwards. So better you start the preparation from second year onwards, so that by the time you come to the third and final year, all the core subjects you will get perfectness and you can attempt the exam. So that is the idea. But there is no restriction for anybody to join any of the courses, and you can join any of the course as you wish. Okay, so I hope you are understanding. Okay, and there is no restriction, there is no bar for any of the people to join any of the course. Just I am telling you ideal conditions. But the advantage of preparing for the GATE computer science is you can crack the ISRO exam, you can crack the BARC exam, NILIT exam, and DRDO also. And all other PSUs who are recruiting computer science graduates like Navaratna, Maharatna companies like IOCL, BHEL and all, so they are taking through the GATE score only. And right now for computer science, ISRO, BARC and NILIT, DRDO, these four are conducting their examination separately. Okay, so I hope you are following. Okay, so now let us go with the faculty who are teaching for this one. Yes, so please you can just post your doubts in the chat box. Okay, so please post your doubts in the chat box if you have any doubts, and even after the class is finished also you can continue asking your doubts in the comment box. So I will reply to your doubts, and please stay in the class till the end, so you will understand here so how to represent a number and how to perform the floating point representation. All those things we will discuss. Very very important topic because definitely either 2 mark question or 1 mark question will come on this number system topic. So now as far as faculty are concerned, so we are having 4 faculty members right now for teaching the gate. One is myself, I have already explained about myself, and the other faculties are Satyanarayana sir is having 13 plus years of experience, and Ankit Doyle sir is having 8 plus years of experience, and Navneet Gupta sir is having 7 plus years of teaching experience. Okay, so this is about the faculty. And before we start the session, so I request every one of you to please subscribe to the channel. So more than 3,12,000 students are subscribed to this YouTube channel of GATE, Gradeup's GATE YouTube channel. Okay, if you subscribe, you will get the notifications related to all the live classes we are conducting on different aspects. Okay, so right now the series is going on 25 most important topics of GATE 2021. So you should attend each and every one of the class. So this is the 19th session. Okay, so this is very useful. So all the basics you will learn, and it is very useful before you are going to the examination. Okay, so please you just say hi or something. Okay, is my voice clear? Everything is fine? Please somebody please respond. Okay, so this is about the faculty which we are having at Gradeup for computer science subjects, right? Now coming to this, so here what my plan of teaching for this today's session is, just I will let you know what are the different types of numbers available and how to represent them, and also a floating point representation briefly I will describe. Okay, so in the examination point of view I will just describe. So conversion from one number system to another number system is very important aspect in the digital logic design, right? Okay, please yes. Yes, Chandana. Yes, thank you for your response. Okay. Yes, Akshay. Yes, you can see the classes, but this class you cannot see in the Gradeup app right now. This is only YouTube session. You can see only in the YouTube, Akshay. So in the Gradeup app, free classes are going on. You could follow me in the Gradeup app. Okay, and you will get notifications related to my classes. So daily free classes are going on in the Gradeup app also. So that also you can see, but this class is relayed only in the YouTube channel, not in the app. Understand? So later on after the class is finished, I will post this link. Okay? Yes. So any others having any doubt, you can post. Okay? I hope every one of you are able to hear my voice clearly, and you are able to see my video also. Is it clear? Please respond. Others too. Okay, and I further request, don't leave the session in between. We are discussing some important problems also in the today's session, and also we are discussing the concepts. Okay, please respond, every one of you, please. And before we start the session, every one of you please subscribe to the channel and also like the class if you are really liking it. Okay, yes, Akshay, thank you so much for your response, Chandana and Akshay. Nice. Okay, so now coming to this conversion from other systems to decimal. Okay, so if you take any number system, so usually what type of number systems we follow in daily representation of numbers? Mostly we follow the decimal system. Okay, so what do you mean by decimal? Decimal is nothing but it is a 10. Any number system we can represent with a radix. Radix is nothing but it is a base of that number. So what do you mean by base? Say for example, if we take a decimal number, the base value is 10, that is the radix value is 10. Okay, so if you take a binary number, for example, if you take a binary number, the radix value is 2. So why it is 2? Because only the numbers 0 and 1 are used in the binary system. In a decimal system, we use 10 digits from 0 to 9, 0, 1, 2 and so on 9, 10 digits we are using. Okay, so in take octal system, for example. So octal system is nothing but it is a base 8, so radix 8. So here 8 different numbers we can use, 0, 1, 2, 3, 4, 5, 6, 7. So these are the numbers in octal. Similarly, we use hexadecimal number system. So in a hexadecimal number system, that is called a base 16. Hexa means 16. So in a base 16 number system, we can use the numbers from 0 to 9 and also hexa digits A, B, C and so on F, A, B, C, D, E, F. These are the 16 numbers. Okay, so like that different number systems are having different base values. Okay, so we can say that something like if I take X, Y, Z base R, for example, X, Y, Z base R means X, Y, Z digits definitely in the range of maximum R minus 1. So in a base R system, we can allow the numbers 0, 1, 2 and so on R minus 1 in a base R system. So that means the value of X, the value of Y, the value of Z cannot be more than R minus 1. So up to R minus 1. So like that decimal, the maximum value is 10 minus 1, 9. Binary, the maximum value is 2 minus 1, 1. And octal, the maximum value is 8 minus 1, 7. And hexadecimal, the maximum value 60 minus 1, it is 15. And we can also have a ternary system. So what do you mean by ternary system? Ternary system is nothing but base 3. So we can have the digits from 1, 0, 1, 2 only. Ternary system is base 3, digits 0, 1, 2, that is a 3 minus 1, it is 2. Like that. So base 4 system will have numbers from 0 to 3, like that. Okay, so up to R minus 1 exactly. So the maximum value. So now very easily I will tell you how to convert any other system to decimal. So converting from other system to decimal is very simple. We have to take the weight of that number. So we have to take the weight of that number. Say for example, I wanted to convert as I told you X, Y, Z. Okay, so X, Y, Z, exactly, Chandana, you are right. Okay, X, Y, Z whole power base R, for example, I wanted to convert into decimal. So that is a base 10 system. So we have to take the weight of that number. So weight of that number is, that is X into R square plus Y into R power 1 plus Z into R power 0. So this first position is called R power 0 position, and second position is R power 1 position, and third position is R power 2 position. So like that we can find out a number and give in the form of decimal. So I hope you are following. So it is very minute, and even at 6th standard, 7th standard itself we used to study all these number systems earlier, but it is very important. Okay, so definitely one question, don't think that it is easy, you can easily do it. So there can be some tricky questions possible here. So you have to do this, then only you have to practice this, then only you can answer any type of question, right? So even the numbers will be given with some decimal point also. Okay, and fraction part, integer part, both you have to understand. So both the things I will tell you very quickly. So we are having a time limit here up to 15, the class is up to 50 minutes. I will try to cover as much as possible. So please be alert and don't leave the session at any cost. Okay, unless you have an urgent work. Okay, so I will ensure that you will get these marks related to the number system, number representation, right? Okay, now coming to one example. Okay, let us suppose I am having a number system like let us suppose I will tell you very simply. I am having a binary. Okay, so there is a binary system like 1011 0.101 0.101 base 2. So this is base 2. Base 2 is nothing but it is a binary system. So actually in a binary system, so before the decimal point, okay, before this fraction point, that is a 2 power 0 and 2 power 1, 2 power 2, 2 power 3, 2 power 4, like this it will come. So conversion from any number system to equivalent decimal value is just taking the weight of that number, and after the decimal point, so it should be 2 power minus 1 and 2 power minus 2 and 2 power minus 3, like this it will go. Okay, so as far as this is concerned, okay, So 1011.101, so base 2 is equal to, so how to convert actually? This can be written as, first of all, 1 into 2 power, because up to 4 digits in 2 power 3 will come, 0, 1, 2, 3, plus 0 into 2 square, hope you are understanding, plus 1 into 2 power 1, plus 1 into 2 power 0. So point of the point again, 1 into 2 power minus 1. Of course, this we can also write as a plus, and plus 0 into 2 power minus 2. Okay, plus 0 into 2 power minus 3. Like this we can represent. Okay, so what is the value of this now? One example I will tell you here. So it is a 8 plus 0 into 2 power 2 is 0. 8 plus 1 plus, yes, exactly 1. 2 power 0 is 1. 8 plus 1 plus 1. So 8 plus 4, 2 power 2 is term is became 0, no? 2 power 2 term is 2, not 1. So 2 power 1 is 2, 2 power 0 is 1. So the value of this is 11. Okay, then now point, it is a 1 by 2. Okay, 1 by 2 plus 1 by 8. So this is 11 point. 1 by 2 plus 1 by 8, what is the value of this? 1 by 2 plus 1 by 8. 2 power minus 3 is 1 by 8. So 8 is LCM, so it is a 4 plus 1, so it is a 5 by 8. So 5 by 8 is nothing but 625. So 11.625 is a decimal value. So 11.625. So I am just not doing the calculations for every problem. So because it is time consuming, because it is easy thing, you can do that. So that's why I am just leaving it to this calculation for future. I hope you understood. Yes, you are right, Chandana, correct. What you have sent is right. Others too, please respond. Okay, I request every one of you to stay in the session, don't leave the session. So there is no advantage if you leave the session in the middle. So that is my request. Okay. Similarly, if I take another value, something like if I am taking, let us suppose 42 point, yes, 42.81, let us suppose 42.81. Just a moment, this is not a octal number because 8 is not a valid octal digit. So 42.31, let us suppose 42.31, it is a base 8 number. So if you wanted to convert into equivalent decimal, so it is a 4 into, because it is a base 8 number, no? So it is a 8 power 1 plus 2 into 8 power 0, 2 into 8 power 0 plus 3 into 8 power minus 1 plus 1 into 8 power minus 2. Understand? So like this we have to find out. Okay. Yes, yes, Akshay, thank you. Now what is the 4 into 8? 32 plus 0, and again, so 2 into 8 power 0 is 1, right? So 4 into 8 plus 2 into 8 power 0 is 2 only. So 32 plus 2 plus, it is a 3 by 8. 8 power minus 1 is nothing but 3 by 8. 3 into 8 power minus 1. So it is a 1 into 8 power minus 2. So 1 by 64. So this value is, I think you can calculate it. So this value is a 34, and after point 3 by 8 plus, what is the value of this? I am just calculating here. 3 by 8 plus 1 by 64 is nothing but 64 is LCM, and it is 24 plus 1. So something like 25 by 64. 25 by 64 you can just calculate and you can write the value. Okay. So that's all we have to perform like this. Exactly. So 34 point something 390 exactly. So this is how we are going to convert from any number system to this decimal number system. Okay. So exactly, let us suppose if I am taking one hexadecimal number. Okay. Something like I am taking 3A2.1D. 3A2.1D, it is a base 16. I wanted to convert into base 10. The conversion from all other number system to base 10. Okay. Yes, every one of you, please, you like the channel and like the class and subscribe to the channel. Please spend 2 seconds of time and then we'll come back. Okay. So meanwhile, I will solve this problem. Right? Okay. So now coming to this, how to find out the weight of this number? So it is a 3 into 16 power 2 plus a means 10. So 10 into 16 power 1 plus 2 into 16 power 0. So plus 1 into 16 power minus 1. Okay, plus d into 16 power minus 2. So very simple, what you have to calculate is 3 into 16 square, I think 256. So and this is 10 into 16, it is a 160. 16 16s, I think 256. Yes, so 3 into 256 plus 10 into 16, so it is 160 plus 2 plus 1 by 16 plus d is nothing but 13. So it is a 13 by 256. This you have to calculate. Then you will get the equivalent value in the decimal. I hope you can do this calculation later on. Okay. So that's all we are going to convert from any number system, even base 3 number system also. So base 3 number system is like, for example, 1210 to 0.100. So 0, right side zeros no values for the fraction part, left side zeros no values for the integer part. Yes. So now if you convert, for example, this is a base 3 number system, I wanted to convert into decimal. So this is also simple. So this is 1 into 2 power 0, 3, base 3 now, 3 power 0, 3 power 1, 3 power 2, 3 power 3, 3 power 4. So 1 into 3 power 4 plus 2 into 3 power 3 plus 1 into 3 square plus 0 into 3 power 1, 3 power 1. Okay, so plus, like that we can do. So 0 into 3 power 1 plus 2 into 3 power 0 plus 1 into 3 power minus 1. That's all. These zeros are, so you can calculate this. Like this we can convert any number system to any other number system. So that is any other number system to decimal number system first. Okay. Now the next topic is how to convert from decimal to other systems. Quickly I will explain. Decimal to other systems, conversion from decimal to other system. So for example, if a decimal number is given, something like any number, okay, so for example 496 point, okay, some 625, this is the base 10 number system. I wanted to convert into decimal. So please observe carefully. I want to convert into binary, sorry, I wanted to convert into binary. Okay, so how to convert? Okay, how exactly we are going to solve this problem? Okay, so now what exactly we can do is the integer part and fraction part separately we will convert. The integer part and fraction part we will convert separately. I hope you are following. Is it clear? Okay, so please like the class if you are really liking it, and don't forget to subscribe the channel meanwhile. Okay, and don't leave from the session in the middle. So please attend the session till the end. Okay, so now what I am doing is this integer part, and we are doing from the decimal to other systems. So each one can be one example I will explain. So that 496. So 496 we have to divide with 2. So 2 2s are 4. Okay, 2 4s are 8. 2 8s are 16. So it is 0 remainder. And 2 1s are 2, 2 2s are 4, 2 4s are 8, 0 remainder. 2 6 are 12, 2 2s are 4 and 0 remainder. 2 3s are 6, 2 1s are 2, 0 remainder. Okay, and 2 15s are 30 and 1 is a remainder. Okay, 2 7s are 14 and 1 is a remainder. 2 3s are 6, 1 is a remainder. 2 1s are 2 and 1 is a remainder. So you have to read them in reverse. So now the value of 496 is 11111 11111 0000. That's all. 11111, 5 ones, 4 zeros. So this is the result point. This fraction part you have to multiply with 2 till you get all the zeros on the right side. till you get all the zeros on the right side. So what is the 2 into 625? So 1250. So we have to write 1.250. So 3 digits you have to use on the right side, and remaining digit you have to send to the before fraction part. So like this we have to continue till you get the fraction part zeros. Sometimes you don't get the fraction part zeros. In that case you have to stop based on the number of bits you are supposed to represent. For example, I wanted to represent the fraction part with 10 bits. Only 10 times 10 bits you consider, remaining you just ignore. Only approximate value we have to consider. Hope you are understanding. Okay. So now again you have to multiply with 2. So 2 into 250, exactly, yes, 2 into 250 is 500. So 0.500. Again multiply with 2. 2 into 500, 1000. So 1.000. So we got all the zeros, we can stop it. So exactly we can represent using 3 bits. So that we can write it as a 101. You have to read these 3 bits. You have to read in the reverse. You have to read from like this, from top to bottom. Okay. So now we will get 111110000.101 is the binary value for a given decimal number. Hope you understood it. Okay. So thank you so much for your response, Chandana and Akshay. Good. That is right answer. Exactly. Okay. Now coming to one more example. So this is the example I took for binary. Similarly, decimal number to octal, one example I will tell you. Okay. Conversion from decimal to octal. Decimal number system to all other system. So to which number system you have to convert? You have to divide with that number. For example, I wanted to convert it to octal, so I have to divide with 8. If you wanted to convert it to hexadecimal, you have to divide with 16. That's all. Okay. Say for example, I am having 430 point something like some 20. 25, 430.25. Okay, so it is a base 8 number. I wanted to convert into decimal. No. We are converting from decimal to octal, right? So this is a decimal number. I wanted to convert into octal. This is a decimal number. I wanted to convert into octal. So as I am converted into octal, so we have to divide the number. So 430. We have to divide with 8. 8 5s are 40, right? And 8 3s 24. So 6 is remainder. So maximum remainder, if you divide any number with 8, is maximum remainder is 7. Okay. Yes, 6 is the remainder. And again divide with 8. 8 6 are 48, so 5 is a remainder. That's all. So there is a, we got 6 5 6. That's all. 6 5 6 .25. We have to multiply with 8 till you get all zeros in the last 2 digits of the fraction part. Yes. Okay. Now 2 into 0.25. How much it is? How much? 25 into 8. 25 into 8 is nothing but 200, right? So 2.00. So you will get with 2.00. So this means that 656.2. That's all. 666.2. That is correct, na? So similarly, one more example I will take. For example, I am having 724.50 base 10. I wanted to convert into octal. So how to do this? 724 you have to divide. 724 you have to divide with 8. So 4 is the remainder. 8 90s are 720. Okay. 8 11s are 88. So 2 is the remainder. 8 ones are 8, so 3 is the remainder. 1324. 1324 point, so 0.50 we have to multiply with 8, so 4.00, that's all. So only 4, so 1324.4, like that we can convert. Is it clear? Is it clear? Yes, please let me know, yes or no. I hope every one of you are following, right? So this is how we are going to convert from decimal to octal system. Yes, exactly, you are right, Ajad, exactly, you are right. Okay, so now coming to the next. Yes, so if you give something like hexadecimal, okay, decimal to hexadecimal, decimal to hexadecimal. So how to convert decimal to hexadecimal? Very simple. So we have to take like this. Let us suppose I am taking some 437.550. So it is a base 10. So I wanted to convert into base 16. Following? Yes. Okay, so base 16 means 437 we have to divide with 16. Okay, and whatever the numbers you are getting, you have to take. So what is the 437? What is the value you will get? You can do this now. 16 twos, 32. So you will get 117. So 16 sevens, 112. So you will get 5 is the remainder. Okay. Similarly, 16 ones are 16, 16 twos 32, 16 ones are 16. So what is the remainder actually? 16 means 7 plus 4. 7 plus 4 is 11. So 11 means B. A, B, C, D, E. Na? So 10 means A, 11 means B, and 12 means C, and 13 means D, 14 is E, and 15 is F. These are the numbers. 15 is F, like this. So now we can get 1B5. Yes, exactly, 1B5. So this is 1B5. 0.50 we have to multiply with 16. So it is 800, right? So 8.00. So 0.8. 1B5 0.8 by 16. 1B5 0.8 by 16. Exactly, you are right, Akshay. Correct. So every one of you please, and I will give you one more example. For example, you are having 500 point, 500 point, yes, 25, 500.25. This is a base 10 system. I have to convert into base 16. So very quickly how to do it? So 500 divided by 16. So 4 is the remainder. Okay, na? So again 16 ones are 16. So what is the remainder? 15. 15 means F. 1F4. 1F4 point 0.25 into 16. 4.00. So this is 0.4. That's all. We can convert like this. So 1F4, not B. not B Ajad, you can just 1 F4. Yes Chandana, you are right. Okay, so this is how we are converting from decimal to other system to decimal. Now sometimes the problems will be given like this. Please observe here, something like, let us suppose it is given like 1A2.3D4. so this is a base 16. so if you are asked to convert into base 8, for example, how to do it? Base 8 is nothing but it's octal system, and base 16 is nothing but it's a hexadecimal system. So what we can do is, first you have to write in a binary coded hexa. So one is, every digit in a hexa is represented with 4 bits like this. So 0 is represented with 0000, 1 is represented with 0001, and so on. F is represented with 1111, the binary equivalent values. Okay, so 1 is nothing but 0001, A is a 10, 10 means 1010, 2 is 0010, 3 is nothing but 0011, D is nothing but 1101, 4 is nothing but 0100. So this is the number actually. So if you group them into group of 3 bits, you will get the octal number exactly. Group of 3 bits. Okay, so these 3 bits is one group and these 3 bits is one group. In the integer part, you come from right to left side zeros you can put, and these 3 1 group. This is 0. And when you are grouping on the decimal fraction, so you have to take the from left to right. So these 3 one group, these 3 one group, and wherever is required you can keep zeros if necessary. So this is nothing but 6, this is nothing but 4, so this is nothing but 2, 642 point, so this is nothing but 1, and this is nothing but 7, and this is nothing but 2, and this is nothing but 4. 642.1724 base 16, sorry, base 8, very sorry, we are converting into octal, so base 8. So the answer is base 8 here, 642.1724, like that you have to divide. So you can keep right side any number of zeros for the fraction part, and for the integer part you can put left side any zeros. Okay, so for example, if you are asked to convert something like, let us suppose one more example. I wanted to convert octal number 4726.0213 base 8. I wanted to convert into base 16, and also what is the value of this equivalent to base 4. Base 4 means what are the numbers I can have? 0, 1, 2, 3. Only 2 bits are sufficient. So quickly I will explain this, then I will go for the representation of floating point numbers. Okay, so now this one, what is the 4 value? 4 value, it is a base 8 means it is a 3 bits we have to use. So 100 is 8, 7 is nothing but 111, 2 is nothing but 010, 6 is nothing but 110, 000, 2 is nothing but 010, 001, 011, like this. Now we have to group them into 4 bits each. So 4 bits from, as far as integer part is concerned, so these 4 is one group, okay, and these 4 is one group, these 4 is one group, because I am converting into 16. So 1001 is nothing but 9, 1101 is 13, 13 means D, C is 12, 0110 is 6, and this one 0000 4 bits, 1000 4 bits, 1001, 1011 4 bits. So this is 0 and this is 8, and 1011 is nothing but B, 08B. So this is 96.08B. And as far as base 4 is concerned, base 4 I am writing, we have to group them into 2 bits each, 2 bits each. So what are those 2 bits? So I will write it once again. Okay, so this part 4726 I am writing once again here. I will do this base 4. Base 4 is only 4 digits, 0, 1, 2, 3. So 4 is nothing but how I have written this? First of all, 1 0. So 1 0 0 is a 4. 7 is nothing but 1 1 1. 2 is nothing but 0 1 0. And 6 is nothing but 1 1 0. 0.000. 2 means 0 1 0. 0 0 1. 3 0 1 1. Right? So this is what? This is a base 8 number. So we have to group them into 2 bits each actually for converting into base 4. 2 bits each. What are those 2 bits? Like this. These 2 bits and these 2 bits, these 2 bits, 2 bits, 2 bits. And here 2 bits, 2 bits, 2 bits, 2 bits, 2 bits. So this is nothing but 1 0 means 2. This is 1. This is 3. This is 1. This is 1. This is 2. This is 0. This is 0. This is 2. 0, 2, 3. So as far as base 4 is concerned, so the value of this in base 4, it is like 213.112.002023 base 4. That's all. This is how we are converting into from hexadecimal to octal or any other number system. Okay. So to converting into decimal is only thing is you have to take the weight of that number. So for example, if you wanted to convert into decimal, so you have to take 1 into 16 power 2 and a into 16 power 1, like that it has to consider if you wanted to convert into decimal, and other systems are represented like this. So that's all about this conversion. Now coming to complements representation. So complements representation means for any base R system, we are having two types of complements. One is a R's complement. So very simply I will explain. One is the R's complement, other one is the R minus 1's complement. R's complement and R minus 1's complement. Let us suppose if n is a given number and R is a radix and small n is a number of digits present in a given number. Okay. So now R's complement is very simple. R's complement is very simple. R's complement is nothing but it is R power n minus n. R power n minus n is R's complement. Okay, for an n digit number. So where small n is a number of digits, capital N is a given number. Okay, as far as R minus 1's complement is concerned, actually these complements representation of this thing is used in performing the arithmetic operations like subtraction and other things. Okay. So R minus 1's complement is nothing but, okay, so R power n minus 1 minus n. So R minus 1's complement of a number is R power n minus 1 minus n. So this is R power n minus 1. So for a base 2 system, we have 1's complement or 2's complement. For example, R is equal to 2. That means a binary system. We can have a 1's complement and also 2's complement. For example, given number n is equal to 1 0 1 0, then 1's complement of the number is 0 1 0 1. That is subtracting every digit from 1 is nothing but 1's complement. 1 minus 0 1, 1 minus 1 0, 1 minus 0 1, like this. And 2's complement is 1's complement plus 1. For example, 1 0 1 0. So what is the 1's complement? 0 1 0 1. If 1 is added, it will become 2's complement. 1 1 is 1 0. Then so 0 1 1 0. 0 1 1 0 is a 2's complement. 0 1 1 0 is a 2's complement, and this one is 1's complement. Understand? Even for a decimal system, for example, if R is equal to 10, so we can have 9's complement and 10's complement. 9's complement and 10's complement, like this. For example, if the number n is equal to some 432, let us suppose. As I told you, the 9's complement is R power n minus 1 minus n. So what is R value here? 10. Number of digits are 3. So it is a 10 power 3 minus 1 minus n. So 10 power 3 minus 1 minus n is nothing but, what is the 10 power 3 minus 1? 999. So subtracting every digit from 9 is nothing but 9's complement. So 9 minus 2, it is 7. So 9 minus 3, 6. 9 minus 4, it is 5. And the 10's complement is just adding 1 for the 9's complement. So 567 plus 1 is 568 is 10's complement, or else a simple way is you have to subtract the first digit from 10, remaining all from 9. 10 minus 2 8, 9 minus 3 6, and 9 minus 4 5, 568. It's a 10's complement. So usually in arithmetic, if you take a minus b for example, so if both are binary numbers, a minus b can be considered as a plus 2's complement of b. So 2's complement of b is b bar plus 1, that is a b bar is 1's complement of b, and plus 1 is addition of 1. That's all. So this is a basic very basic representation of these complements, and they are used in the further representation of this arithmetic operations. Signed integer representation, like we can have signed 1's complement, signed 2's complement, signed magnitude. In performing some arithmetic operations like borrow subtraction, normal subtraction, all these things it will be used. So please like this channel and like the class and share the channel. Don't forget to share the channel and like the channel and share with your friends and subscribe to this channel. Okay, so don't forget to that, and please stay in the session for further 10 more minutes, so we can just finish this floating point representation. One more example I will tell you. Okay, so please. So now here one more thing is BCD and binary difference I will tell you before we go for the floating point. BCD and binary difference. Binary means just a number is directly converted to binary given number. BCD means binary digits, like we have taken a decimal digit from 0 to 9. So we can represent every digit from 0000 to 1001. That is called BCD. Something like if I am taking a number 12. Number 12 BCD representation is 1 is represented like 0001, 2 is represented like 0010. But binary means directly 12 is represented like 1100 as a binary. So 12 is not a valid BCD digits. Valid BCD digits are from 0 to 9. Okay. For example, if I am having 143 binary, if you want means, so you will divide this like this. But 143, if you wanted to represent in BCD, 1 is represented with 4 bits 0001, then 4 is 0100, and 3 is 0011, like this it will represent. And binary value, we just divide this. 2 7s are 14, 2 1s are 2, and 1 is a remainder. Okay, and again 2 3s are 6, and 2 5s are 10, and 1 is a remainder. 2 1s are 2, 2 7s are 14, 1 is a remainder. 2 8s are 16, 1 is a remainder. 2 4s are 8, 0 is a remainder. 2 2s are 4, 0 is a remainder. 2 1s are 2, 0 is a remainder. So the binary value of 143, 1000 1111. Like this we can represent binary. But BCD is like this, 0001. Every digit is represented like a binary coded decimal. I hope you are understanding. Okay. So the addition of binary numbers is different, BCD numbers are different, so both are different representations. Okay. Now coming to the floating point representation. So floating point representation, very quickly I will tell you. So here we use the IEEE notation. We have to use the IEEE 754 notation. IEEE 754 notation is the standard notation we use for representation of 32-bit single precision numbers, 32 bits float. So if we declare any variable as a float type in C language, so it will reserve 4 bytes of memory, right? So 32 bits. Clear? Okay. So please like the class if you are really liking it, and stay in the class till the end. So don't leave in the middle. Okay. Fine. Okay. So now please quickly, the floating point numbers are represented like 3 categories here. Sign will be there. Sign followed by exponent followed by mantissa. Sign followed by exponent followed by mantissa. So mantissa is a fraction, 23 bits, and exponent is 8 bits, sign bit is 1. So there is one formula which you have to remember. So number n is equal to, so this is for single precision. Single precision. So number n is equal to yes minus 1 whole power sign into 1 point fraction into 2 power exponent minus 127. This is the formula where 1 less than or equal to exponent less than or equal to 254. 1 less than or equal to exponent less than or equal to 254. Okay, if exponent value is 0, that is a different case. Okay, for otherwise. So this is the single precision representation of IEEE 754 floating point numbers. So minus 1 whole power sign. Sign value generally for a negative number, the sign value minus is 1, and for a positive number plus the sign value will be 0 we use. Is it clear? Okay. Now any number, first of all you have to convert into binary given decimal number. Okay, then we have to represent in the form of floating point. One example I will tell you. Okay, something like we are having minus 40.625. Minus 40.625. I have to represent this decimal number in the form of IEEE 754. So 40 is nothing but it is a 32 plus 8. So 2 power, the binary value is directly I am writing 2 power 5 is 1, 2 power 4 is not there, 16, 2 power 3 is there, and 2 power 2 not there, 2 power 1 not there, 2 power 0 not there, 0, 1, 2, 3, 4, 5. Okay. So 0.625. So 0.625 you have to multiply with 2. So 625s are 1250. So 1.250 and 250s are 500. So 0.500. 2 500s are the 1000, 1.000. So 101 is the result. So 101 is the base 2, but it is a negative number. So please observe carefully. We have to write in the form of 1 point fraction format. So that is called a normalized. So without meaning change, 0, 1, 000 should go to after the decimal point. So I am writing this as 1.0100101 into 2 power 5. Why 5? Because 5 bits are moved. Because the scientific notation we used in the floating points are m into r power e notation, where m is a fraction and r is the radix and e indicates exponent. This format. So it is very simple to know the decimal numbers. Like for example, if a decimal number is like 4352 for example, I can write this as a 4.352 into 10 power 3. This is called scientific notation, or we can also write it as a 0.4352 into 10 power 4 also. If you multiply with 10 power 4, the number remains 4352. Okay, so that's all. But before the decimal point, if a non-zero value is there, that is a normalized. If a zero value is there, that is unnormalized. Okay, so 1 point fraction format we have written, and for this biased exponent you have to take, because this is something like exponent minus 127. Okay, so exponent minus 127 is equal to 5. And what is exponent value? Exponent value is equal to 127 plus 5, it is 132. So we know the exponent value, we know the sign value, it is a negative, that is a 1, and we know the fraction value. Fraction value is what? So 0, 1, 0, 0, 1, 0, 1, and you can keep right side any number of zeros. So I am writing now, sign is this, exponent 132 value in binary is 1000, and 132 means 128 plus 4. So it is a 0100. So 1000, 0100, then this fraction value. So 0100101 fraction value total. We are having how many bits? 23 bits. Okay, so 23 bits means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. That's all. So these are the 23 bits in a 32-bit representation of the number. So you can also represent like a hexa code. So what is the hexa code for this? I'll just take it. So you can divide them into 4 bits. So these 4 bits, these 4 bits, these 4 bits, these 4 bits, and these 4, and you can divide these 4 and 4 and 4. So this will become actually C 2 2 0 1 0 1 means what? 5. C2250000. So we can represent this like a 0 cross C2250000 in hexa format, or else 1632 bits you can represent like this. So this is how we are going to So how it is converted? Minus 40 is very simple. So if you divide like this base 2, so 2 20s are 0 and 2 10s are 0 and 2 5s are 10 0, okay, and 2 2s are 4 and 1 is remainder, 2 1s are 2, 0 is remainder. So 101 followed by 4 zeros, 101 followed by 3 zeros, sorry, not 4 zeros. But directly how I have done is 2 power 5 is 32, 2 power 3 is 8. So 2 power 0 term it is, 2 power 1 term, 2 power 2 term, 2 power 3 is 8, 2 power 3 is there, and 2 power 4 not there, 2 power 5 is there. So 32 plus 8 is nothing but 40. So in the powers of 2 I have written this. Okay, so that is how we are doing this, and this is all about floating point representation, and I hope you have enjoyed the session, right? And finally I will give you one more example on this floating point representation very quickly. Please take it. 9.25 minus 9.25 base 10 I am converting into IEEE 754 notation. So 9 is nothing but, every one of us know, it's very simple. So 1001. So 0.25 is, you multiply with 2, 0.50, 2 into 50, so 100, so 01. So 1001.01 base 2. So this is the negative number. 1 point fraction format you have to write. So 1.00101. Understand? Okay. So please watch carefully. Okay. Into how many negative value only? So 3 bits are moved. So into 2 power 3 we have to write. Now exponent value, biased exponent 127 we should add. So exponent minus 127 is equal to 3. Exponent is equal to 127 plus 3. So it is 130. 3 plus 127, okay, and sine value is 1, exponent value 00101. So sine is 1 and exponent value 130, the binary value of 130 is 10000010, 128 plus 2, and fraction value 00101. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, that's all. So we have to divide them into group of 4 bits each. So see this how I will divide. I will just show you with a red color. Now these 4 bits are one group, these 4 bits one group, these 4 bits one group, these 4, and remaining all are zeros only. You can divide them like this. Okay, this will be C1140000. So we can call it as a 0 cross C1140000. That's all. Okay, na? So thank you so much. That's all for today, and I hope you enjoyed the session. So before concluding the session, so let us all congratulate our Gradeup achievers. Under the GATE and ESC category, more than 60 students of Gradeup are in top 100. So all India ranks they have achieved. And in computer science we got 4th rank and 20th rank, 39th 2 people and 47th rank. And in 2018 both in the engineering services, EC is top rank, all India first rank. And in 2019 both mechanical students, one have got 10th rank, one have got 27th rank. So let us congratulate all these Gradeup achievers. I wish every one of you also who are writing the 2021 GATE exam all the best. I wish every one of you to be in this list. Okay. Yes. Now coming to Gradeup Super. Under Gradeup Super we are having structural live courses which includes India's best faculty interaction and complete doubt resolution instantaneously, and full syllabus coverage for your examination. Under the green card, so online mock test will be there, all are designed by the toppers based on the latest exam pattern. You can reach us at 96500 related to any doubts related to this. And Gradeup Super is a one-stop solution for all your preparation needs. Okay, all the structural live courses you can access unlimitedly, and you can take the subscription the duration wise. Okay, so this is the fees actually. If you take a 3-month subscription, 9,000 rupees you have to pay for 12 months, 22,200 for 18 months, it is 30,600, for 24 months it is 36,000. So you can go to the Play Store and download the Gradeup app, and you can unlimited access to this by subscribing the Super. Okay, and if you have any doubt, you can reach us at help@gradeup.co. or you can also reach us at 96500529004. So that's all about for today. I wish every one of you very good luck. Okay, and I hope you have enjoyed the session. Is it so? And still, if you have any doubts, you could ask me, and you can also continue asking your doubts in the comment box of the YouTube portal. Right? So thank you so much. Thank you one and all. Hope you have enjoyed the session, and looking forward your participation in more of these sessions. Thank you so much. Okay, and very good night. Okay, so go grade up, prepare smart, score better, and stay safe. Thank you. Have a good night.